Hello, welcome to part 2 of Physics Paper 2 AQA Higher 2018. Okay, so last time I was talking about spring, talking about this experiment here. Okay, so we're carrying on from last time. We talked about how we do the experiment and about inaccuracy. So the next question is about a bit more about inaccuracy. Give myself a bit of room there. So the student measured the extension for 5 different forces rather than measuring the extension for one force. Explain why. So we were talking a little bit about this, about repeating an experiment. I'm going to put a text box so I can write on the page. As you all know, my word's a little bit temperamental. Just adjust this as a bit of a lesson for you, Nighty. If you want to write on Word, you put a text box in, much easier. Okay, right, so suggest why. So there's only one mark, so it's not very long. So you could say to identify anomalous results. Okay, so when you plot data, especially if you're going to plot a graph in a minute, as you can see underneath, if you have anomalous results, it can actually really throw data off. If you have anomalous results, they always try to eliminate as many anomalous results by getting as much data as possible. Okay. It's actually there actually allow you to say more accurate. Okay, so actually the mark there is quite easy to get. I'll say you repeat it to get rid of anomalies. Okay, extension in centimeters. So we've got a graph here. Kind of knew that was coming, didn't we? Complete figure 2 by plotting the missing data from table 1. Draw the line of best fit. Okay, table 1 is repeated here to help you answer the question. Okay, it's this one. Let's up a little bit. Right, so we've got 0, 2. Oh, 2's not there. That's what's not there. So 2 and, yeah, in order. 2 and 3.5. Okay, so 2 and that's 2.5. So each one 2.5. So each one is, so 5 times 10, so it's 0.2, 0.4, 6, 5. Each one's 0.5. That's the hardest bit in this, is figuring out what the scale is. Okay, so that's 0.5. That's 2.5. 3.5 would be there. Okay, so let me just get insert shape. So you can do this on Word. Okay, so 2. We'll put X. I've got here. So 2.5. 2.5. X will be there. Okay, that's one of them. Okay, so what's the missing data? So we've got 2, 4, 6, 8. So 2, 4, 6, and 8 was 16. So it will be it'll be up there somewhere. Let me just try and move that up a bit. Sorry about this. Right. Okay, so we're missing 8. So 8 and 16. So that's 15. So 16 will be 2 tiny squares above. So we're going to copy and paste the X. Just to move it, I'm going to do this. Make it smaller when I get there. Okay, so it's going to be there. I'll draw the other line with shape. Cool. As long as I center of the X. So we've got a very, very straight line. That's very unusual for real data. Okay, usually it's not as nice as that, real data. Okay, so what's our next thing to do? Draw a line of best fit. So it's nice and easy, isn't it? Just draw a line through the points. So sometimes the line of best fit doesn't go through the points, but in this case, pretty much will. So let's try this. And I've got a straight line. You use a ruler. you're gonna get, yeah, you're gonna get a little bit of either side like that. That's normal. It's going like that. So that one's above, that one's below. That's how it normally is. You don't usually get all the lines exactly. Okay. It's real data. It's usually you actually get more often than that. Okay, write down the equation that links force, so extension, force, and spring constant. So force equals spring, in words, constant times extension. We're talking about that extension, not the whole length of the spring. That's quite a common error people do. Okay, calculate the spring constant of the spring the student used. Give your answer in newtons per meter. So we're going to have to use the graph. Okay, so force. So let's have a look. Let's go where it's, of course, it's at a convenient point here. We'll choose a convenient point. I mean, there's lots of things we could choose, isn't there? I'm trying to think of the easiest for us to look at. It crosses the line. We'll choose here. This is force in newtons, so that's 5. It says 0. So it's 2.246, 2.6 newtons. We'll write it down here. Give it a space. 2.6 newtons. And extension 2.6. Was 5. Okay, so I chose it. Nice and easy. So yeah, always choose the convenient point. You have to make your life difficult. Okay, so we are the force is spring constant times extension. So 2.6 newtons equals, we'll go for, because K is a spring constant, times extension. But aha, right. So extension here is in meters. Okay, that's 5 centimeters. So it's 0.05. Okay. So then we rearrange it. With K equals, should be a small k, equals 2.6 divided by 0.05. So let's do that with calculator. 2.6 divided by 52. So we get 52 K spring constant, and they give us the newtons per meter. So you'd write that in there in your exam. Sort of write it here just to work out to show you. It's from the graph. Okay, so it might vary a little bit according to how you plotted that graph, but it's pretty much close to 50, 52. Okay, that's that next one. Hooke's law states that the extension of an elastic object, so I said elastic band for the spring constant too. Okay, the extension of an elastic object is directly proportional to the force applied, provided the limit of proportionality is not exceeded. Okay, the student concluded that over the range of the force used, the spring obeyed Hooke's law. Explain how the data supports the student's conclusion. So our graph was very linear. Okay, so it's a straight line. So a straight line indicates a directly proportional relationship. So let's put that in. Okay. Let's get rid of this box a minute. Might as well build it all room. I'll just question for a minute. Bear with me. What would you undo? Do it again. Okay, I'm going to write the answer. Get rid of this. I'm going to write the answer to this question here. A bit of a computer error. Okay, in the exam, obviously you just write it in pencil. So the line is straight. Okay, the line is straight. I'm trying to do this. Okay, figured it out. So the line is straight, so indicating direct proportionality. And the line passes through the origin. It didn't. It might not be direct proportional. There could be other things going on. Remember, talking about extension, not the actual length of the spring again there. So that's why it passes through the origin, because the original 0 was the unstretched spring. Okay. So P waves and S waves are two types of seismic wave caused by earthquakes. Which one of the statements about P waves and S waves is correct? Okay, so we can do it by process of elimination. So P waves and S waves are transverse. No, not both transverse. P waves and S waves are longitudinal. Nope. P waves are transverse and S waves longitudinal. No. P waves longitudinal, S waves are transverse. So P waves, also known as pressure waves, are longitudinal. Okay, so they move back and forth. Whereas S waves, or secondary waves, or shear waves, okay, are transverse. Okay, remember the S is like a transverse wave. Okay, for S sort of like a sine wave, or sort of it goes up and down. So we just put the tick in the box there. Put the tick not across, if you remember. You can actually get a tick, can't you? Yeah. We'll just draw it today. But in the exam, you'll just be ticking off with a pen. Nice and easy. Shapes. So tick in the fourth box. That's it for that one. Okay, seismometers on the Earth's surface record the vibrations caused by seismic waves. Figure 3 shows the vibration recorded by a seismometer for one P wave. Okay, so you've got a wave. Calculate the frequency of the P wave shown in figure 3. So we've got a time, 10 seconds. So how many wavelengths are going past this point? So remember, frequency, okay, is how many wavelengths pass a point per second. Okay, so let's just write this down. So I'm going to insert text box and start working something out. I'm figuring out how to do this now. Okay, break it down. I've got two text boxes and didn't that. Oh well, hang on. Let's go down. Okay, there. So calculate the frequency. So we've got 10 seconds. How many wavelengths? So we've got one total one there. So 1, 2, 3, 4. Okay, so we've got how many waves in one? So 10 seconds and you've got 4 wavelengths. Check that again. Oh, miscounted, but we miscounted then because I did so peak to peak. Let's do peak to peak. Yeah, it's easy to make a mistake with this one because it's got a strange shape. 1, 2, 1. Okay, and then 2. Okay, so 2. Wavelengths. what I'll do, because we're sort of getting to the end of the time, what I'm going to do there, I'll take the this into the next video. Okay, and I'll explain in the next video. So I'll mark up this diagram and explain in part 3. Thank you for listening, and see you in part 3. Thank you. Bye.